Thousands of soldiers bled out in agony within the ice-cold currents of the Dnieper because the Red Army faced an insoluble geographical riddle that devoured every strategic plan. Yet, the engineers' answer to this mass tragedy was not a triumph of technology, but a grotesque experiment, a mechanical hybrid so absurd that it often posed a greater threat to its own crew than to the enemy. Why did the Soviet industry spawn a colossus whose physical dimensions eclipsed even heavy main battle tanks, yet possessed armour so ridiculously thin that it could be perforated by a simple infantry machine gun? What dark secret did one of its designers have to suppress, risking his own career and freedom, just to force a machine to literally vomit mud and escape a fatal humiliation during state trials? This is the black file of a vehicle that its own units cursed as the floating coffin. An armoured beast that was senselessly sacrificed in the scorching wastes of Egypt, only to inexplicably sink entire fleets of warships in the suffocating swamps of India years later. We will unveil the abysmal design flaws that were marketed as brilliant innovations, and show you why this steel monster, despite its total technical obsolescence, refuses to finally die on the modern battlefield. The experiences of the Second World War ruthlessly exposed one of the most crippling logistical and tactical vulnerabilities of the Red Army. Forcing water obstacles under combat conditions remained a nearly insurmountable task. During the westward advance between 1943 and 1945, troops were compelled to cross an immense number of rivers, lakes and estuaries, where geography itself acted as a relentless adversary. Most rivers in Eastern Europe flow in a meridional direction, and due to the Coriolis force of the Earth's rotation, the western banks are typically steep and high, while the eastern banks are flat and shallow. This topographical asymmetry transformed every river crossing into a lethal trap, as defenders on the elevated western banks held ideal firing positions. The technical equipment of the engineering corps was utterly inadequate for modern manoeuvre warfare. The most advanced pontoon park of the era, the N2P, had to be transported on trailers towed by agonizingly slow tractors of the 65 type, which reduced the marching speed of the engineers to a pathetic crawl. There were no self-propelled crossing means capable of following armoured assault formations at the same tempo. The few surviving amphibious tanks from the pre-war era were effectively useless due to their anemic armament and lack of transport capacity for other units. This glaring void led to catastrophic scenarios, such as in the autumn of 1943 at the Dnieper, when motorised battalions of the 3rd Guards Tank Army crossed the river on improvised rafts and fishing boats, only to be stranded on the far bank without heavy weapons. The essential pontoon bridges for tanks and artillery did not arrive until 14 days later, a fatal delay that allowed the enemy to completely liquidate the bridgehead and establish a deeply echeloned defence. Although American amphibious vehicles delivered under the Lend-Lease program, such as the Ford GPA, provided some relief, these unarmoured vehicles were extremely vulnerable in direct fire combat. With the onset of the Cold War and the shift of potential conflict to the Central European theatre, where a water barrier obstructs the path every 40 to 50 kilometres on average, the problem became critical. To maintain the required high tempo of attack, the army desperately needed armoured vehicles capable of overcoming these barriers from the march, without losing precious time waiting for the laborious construction of bridges. The Soviet military leadership reacted with requirements that bordered on technical lunacy and presented engineers with physical impossibilities. The new technical specifications demanded the creation of a mechanical chimera. A floating light tank was to be created that was not only armed with a 76mm gun, but also served as a transport for 20 infantrymen. The development of this hybrid was entrusted to Factory No. 112, Krasnoye Sormovo, a shipyard that now faced the complex task of merging shipbuilding with tank construction. The result, known as Object R39, was a technical catastrophe. Engineers desperately tried to integrate contradictory requirements into a single vehicle, but failed grandiosely against the laws of hydrodynamics and statics. During factory trials, it became clear that the vehicle, due to an excessively high centre of gravity and flawed mass distribution, possessed a life-threateningly low stability in water and threatened to simply sink. The armour was paper-thin, the speed in the water via the inefficient propeller drive was pitiful, and the mechanical reliability of the overloaded chassis was non-existent. This fiasco led to the immediate termination of the R-39 project, leaving the army once again without the much-needed amphibious combat vehicle. Following the shipyard industry's resounding failure to deliver a functional amphibious tank, responsibility was transferred by Soviet Council of Ministers Decree No. 3472 on August 15, 1949, to the All-Union Scientific Research Institute of Transport Machinery, or VNII-100 in Leningrad. The imposed timeline was an absolute bureaucratic fantasy, as prototype testing was scheduled to begin by late 1950, leaving engineers with barely 12 months for a complete ground-up development. Within the design bureau, a fierce technical feud erupted over the method of aquatic propulsion, perfectly illustrating the fracture in Soviet engineering of that era. While the conservative wing under chief designer Kotin and engineer Troyanov clung to obsolete, folding propeller screws, engineer Shashmurin realized that exposed propellers would be extremely vulnerable in rough terrain and utterly useless in weed-choked waters. Only through direct intervention with the Minister of Transport Machine Building, Malyshev, did Shashmurin manage to force through the risky but innovative idea of water-jet propulsion against the fierce resistance of his superiors. Parallel to the work in Leningrad, a rival team in Moscow under Colonel Kravtsev developed the K-90 tank, which technically relied merely on the chassis of the M2 artillery tractor and stubbornly adhered to the antiquated propeller technology. This rivalry culminated in July 1950 with a comparative trial that resembled a farce more than a serious military evaluation. To test mobility under extreme conditions, the chairman of the State Commission, Colonel General Poluboyarov, ordered both prototypes to cross a drained mill pond that was essentially a lethal trap of thick, viscous sludge. The Moscow-based K-90 failed spectacularly after less than 5 meters, when the mud jammed the unprotected propeller drives, stalling the engine and leaving the vehicle sinking helplessly in the quagmire until it had to be salvaged by a recovery tractor. Leningrad's Object 740 also found itself in a critical situation, grinding to a halt after about 10 meters as the dense silt choked the intake ducts of the water jets and a massive wall of mud built up before the bow. However, the designers utilized a specific characteristic of water jet propulsion that is physically impossible with propellers. They engaged the transmission's reverse gear while the water jet pumps continued to run. Through this improvised flushing process, they managed to blast away the mud beneath the hull and in front of the bow, providing the armoured vehicle with the necessary thrust to break free and overcome the obstacle. This moment of technical improvisation saved the project from oblivion and sealed the fate of its propeller-driven competitor. Yet victory at the trials by no means meant that the troops would welcome the new vehicle, later known as the PT-76, with enthusiasm. On the contrary, due to its gargantuan dimensions, which even exceeded those of the T-54 medium tank, and its paper-thin armour, soldiers branded it with derisive nicknames like the Floating Coffin, or simply the Bobber. The discrepancy between the physical proportions and the actual combat value of this vehicle was nothing short of grotesque, as the relentless laws of buoyancy dictated a design that forced engineers into compromises undermining any practical military utility on land. To achieve the necessary displacement for a total mass of 14 tons, the hull had to be designed as a voluminous, flat-bottomed barge. This transformed the vehicle into an immense, nearly unmissable target on the battlefield, one that was paradoxically larger than the far more powerful T-54 medium battle tank. Engineers were further compelled to reinforce the dangerously thin armour plates, which measured a mere 15 millimeters at their strongest points, and offered little more than protection against light small arms, with a complex internal skeleton of specialised support struts and gussets known as pillars. Without these, the hull would have collapsed like an empty tin can under hydrostatic pressure in the water, or during jarring impacts on rough terrain. Inside this floating metal box worked a V6 diesel engine, which was essentially a technically halved engine from a heavy tank. Its output of 240 horsepower was barely sufficient to move the Colossus with any agility on land, resulting in a humiliatingly low power-to-weight ratio. Another technical curiosity was the overcomplicated safety mechanisms designed to prevent the engine from drowning if it stopped in the water. This failure-prone system, controlled by falling oil pressure, automatically closed protective flaps in the 6 exhaust pipes upon engine stall while simultaneously opening drain valves. Paradoxically, this directed any infiltrating water first into the interior of the tank, from where it had to be laboriously pumped back out by bilge pumps. While the vehicle appeared sluggish, noisy, and underpowered on land, the waterjet propulsion revealed its only true technical sophistication once in the liquid element. Steering was not handled by inefficient external rudders, but through the hydraulic closing of the exit flaps, allowing the tank to pivot almost on the spot and even fire its main gun while swimming. Nevertheless, its tactical classification remained an absolute disaster. With the advent of nuclear doctrine in the 1950s, priorities shifted radically, and the need for specialized weakly armored amphibians for massed first-wave river crossings vanished. The unwanted PT-76 tanks were subsequently pushed into reconnaissance units out of necessity, where their flaws became even more glaring. For a scout intended to be stealthy, the vehicle was far too voluminous, harder to camouflage than a main battle tank, and so slow off-road that it frequently lost contact with its own marching columns. The irony of history reached its peak when the introduction of the revolutionary BMP-1 infantry fighting vehicle in the late 1960s made the concept of this clunky swimming tank definitively obsolete in the European theatre. It seemed the machine was destined for the scrap heap, before it experienced a completely unexpected and bloody renaissance in the distant tropics. The true absurdity of this constructive concept only manifested in its full starkness when the vehicle was exported to geographical regions for which it was neither designed nor suited, leading to diametrically opposed operational results. In the Middle East, where the Egyptian army received 50 units in the mid-1960s, the PT-76 was completely misused as a conventional battle tank in the open desert during the Six-Day War of 1967. Deprived of its protective water refuges and betrayed by its enormous silhouette, the bobber became an ideal target on the arid, stony soil of the Sinai, its thin tin shell easily perforated by even light-caliber weapons. The result was a military debacle in which 29 vehicles were neutralized in record time or abandoned by fleeing crews, after which the Israeli army captured the intact trophies to, paradoxically, upgrade them with new engines and American machine guns. In total contrast, the fate of this tin box took a radical turn in the humid labyrinth of the Ganges Delta during the Indo-Pakistani conflict of December 1971, where its chronically weak motorization and light armour were compensated for by extremely specific terrain conditions. There, Indian forces faced Pakistani M24 Chaffee tanks, which were technically superior as light tanks and better armed, but hopelessly bogged down in the swampy ground and at the countless river arms. In this precise scenario, the PT-76 transformed from an obsolete problem case into the only viable operational tool, overcoming obstacles with its water jets that were absolutely impassable for any conventional tracked vehicle. One of the most singular incidents in modern military history occurred on December 9th, when a company of these amphibious tanks reached the port of Chandpur and opened fire on 3 Pakistani river gunboats. A land-based armoured vehicle effectively assumed the role of a destroyer to sink the enemy flotilla with its 76mm gun, which was actually considered too weak for ground combat. Days later, the 69th Tank Regiment demonstrated the strategic mobility of the system by conducting a 55-kilometre march through supposedly impenetrable jungles and swamps, bypassing enemy defensive lines to capture the city of Bogra in a surprise attack. This success, however, must not obscure the fact that the triumph relied less on technical excellence and more on the fortunate circumstance of facing an opponent who lacked any adequate anti-tank weapons in that sector, which would have instantly turned this floating coffin into an incandescent wreck. Despite these exotic successes, the fate of the model in the world's major armies was sealed, and by the end of the 1990s the PT-76 had almost completely disappeared from Russian inventories, as it no longer possessed any chance of survival on a modern battlefield. Paradoxically, the apparent conclusion of its operational service within regular forces did not signify the absolute death of this controversial concept, as 21st century Russian engineers decided to subject the obsolete hull to a radical metamorphosis that rendered the vehicle technically unrecognizable. The fundamental logic behind this profound modernization rested on the pragmatic realization that reinforcing the armor was physically impossible without sinking the machine. Therefore, designers focused exclusively on a drastic increase in firepower. In a surprising turn, they rejected the 90mm cannon from the Belgian firm Cockerill. Analyses had ruthlessly demonstrated that a slow-firing heavy gun would remain impotent against the frontal sector of modern main battle tanks, whereas a 57mm automatic cannon, derived from the old SE-60 anti-aircraft piece, offered far superior tactical flexibility. Ballistic calculations mercilessly exposed the weaknesses of conventional armament. The probability of annihilating an infantry fighting vehicle at a distance of 2 kilometers using automatic bursts was 1.75 times higher than with a classic large-caliber artillery shell. Furthermore, the infernal rate of fire of 120 rounds per minute offered, for the first time, a genuine chance to neutralize helicopters and drones, against which the original design was completely defenseless. To exploit this new weapon station, an automated fire control system was integrated, reducing the stabilization error during full-speed travel to less than 0.5 milliradians, allowing the armored vehicle to deliver a level of precision that crews in the 1950s would not have dared to dream of. Even the chronic problem of mobility, which had turned the tank into a sitting duck for decades, was addressed through the radical transplant of a new heart. The installation of the 300 horsepower UTD-23 diesel engine finally raised the power-to-weight ratio to 20 horsepower per ton. These measures transformed what was once derided as a tin coffin into a bizarre technological hybrid that, while retaining the vulnerability of a light boat, now possesses the ability to autonomously scan an opponent's optical sighting devices and align its turret front against the threat in a fraction of a second. Thus, the history of this machine does not end as a mere forgotten historical relic, but as proof that even a fundamentally flawed design can be kept artificially alive through the near-total replacement of its organs, at least as long as a customer remains willing to pay for the illusion of a modern light tank.